Hello everyone, we continue for our group 14 lesson. Okay, for today, I want to explain more about characteristic of monoxides of group 14 and dioxides of group 14. Okay, so now for characteristic of group 14, I will explain about thermal stability, acid base property, bonding and structure. Okay, I start with thermal stability that we already learned before. Okay, for thermal stability, okay, as you learn, carbon monoxide and titanium monoxide is easily oxidized to form dioxides when heated. Okay, while lead ore is depends on temperature. Okay, so this is you already know that lead monoxide is stable to heat since its positive to oxidation state is more stable than its positive for oxidation state. Okay, so now let's rewrite again the chemical equation of thermal stability, okay, of carbon monoxide. We start with carbon monoxide. Alright, okay, we react with oxygen, okay, and then it will form carbon dioxide. Okay, and then balance the equation. Okay, so same goes to silicon monoxide. Okay, once you react with oxygen, then it will form silicon dioxide. Okay, and then balance the equation. Okay, and then followed by germanium monoxide. Okay, germanium monoxide, and then plus oxygen gas. Okay, and then it will form germanium dioxide. Okay, then balance the equation, and finally tin monoxide plus oxygen gas, it will form tin dioxide. Okay, and then balance the equation. Alright, so for lead monoxide, actually it can oxidize, alright, to form a new compound, but it must followed by higher temperature. So let me see, lead monoxide. Okay, lead monoxide. Okay, when we heated with oxygen, okay, off, and we increase the temperature until 400 degree Celsius, it will form triplumbum tetroxide, okay, Pb3O4. Alright, okay, but it must give the higher temperature until 400 degree Celsius. So and then balance the equation. So now is 3, so this one is 3. Okay, and then so this one is, okay, oxygen, so this is okay, 2 here. Okay, so 6. So oxygen enough. Alright, so this is the reaction of lead monoxide. Okay, by given the 400 degrees Celsius, it will form triplumbum tetroxide. Okay, if you further heating of this triplumbum tetroxide, you will get back, okay, 470 degrees Celsius, you will get back the lead monoxide and oxygen gas. So this is the reaction of monoxide. Alright, and then okay, we take a look for dioxide, okay, which is positive for oxidation state. Okay, for thermal stability of carbon monoxide, okay, until tin monoxide, okay, these 4 of dioxides of group 14 element is stable even in higher temperature. Okay, hence only lead dioxide will decompose to lead monoxide and oxygen towards heat. So this is the equation. Let's redo the equation. So lead dioxide, okay, when we heat, okay, so it will decompose, alright, Okay, it's easier to decompose to lead monoxide and oxygen. So lead dioxide, it easier to decompose into lead monoxide and oxygen gas. Okay, then we balance the equation. So this is the positive 4 oxidation state and this is positive 2 oxidation state. So that's why lead, okay, is stable in positive 2 oxidation state. Lead, we have 3 types of lead here. So we have lead monoxide, okay, and then we have lead dioxide here, and also we have okay, triplumbum tetroxide here. So okay, so we have 3 types of lead compound with different oxidation state. So okay, for lead monoxide is a positive 2 oxidation state, while lead dioxide is positive 4 oxidation state. Okay, and triplumbum and tetroxide, it is positive 2 and positive 4. So from the chemical equation here is actually, okay, after we hit the lead monoxide, okay, with oxygen, okay, actually here is we get lead dioxide. Okay, so we get lead, okay, dioxide plus lead monoxide. Alright, so this one is a ratio 2:1. So that's why we get that triplumbum and tetroxide is the oxidation state is positive 2 and positive 4. So this positive 2 is referred to lead monoxide, okay, and positive 4 is referred to the lead dioxide. Okay, so now we take a look about the color. Okay, so these 3 types of lead compound, okay, have different colors. Okay, so for lead monoxide, it is the yellow color. Okay, yellow color. Okay, while for lead dioxide is a brown color. Okay, brown color. Okay, and for triplumbum and tetroxide is a red color. So that's why we call of triplumbum and tetroxide as a red plumbum. Okay, so now, okay, how to memorize the color? Okay, for lead O and lead O2, okay, actually is I use this formula. Okay, next properties is acid-base properties of oxides of group 14. Okay, so now for monoxide, okay, for monoxide, okay, for carbon monoxide and silicon monoxide, these both monoxide are neutral. Alright, okay, while for germanium monoxide, tin monoxide and lead monoxide are amphoteric. So for amphoteric, as you know that it can react with acid and base. Okay, while for neutral, it cannot react with both. Okay, and then for dioxide of group 14, okay, carbon dioxide and silicon dioxide are acidic. Okay, while germanium dioxide, tin dioxide and lead dioxide are amphoteric. So this property you must memorize it well lah. Okay, so now, okay, when we talk about acid-base property, okay, you have to know how to write down the chemical equation. Okay, especially for amphoteric, you must know how to write the chemical equation of both. Okay, let's say that germanium monoxide react with acid and germanium monoxide react with base. Okay, now let's write the chemical equation of amphoteric. Okay, so now is, okay, let we see the reaction of germanium monoxide. Okay, first germanium monoxide which react with any acid. So I pick that HCl. HCl, hydrochloric acid. Okay, so germanium monoxide, when it react with hydrochloric acid, so it will get germanium dichloride, okay, and plus water. Okay, and then finally is you just balance the equation, and then H2 here. Okay, so and then second one is a tin monoxide. Okay, try to write the equation. Tin monoxide, you react it with HCl. So basically, okay, when it react with acid, that shows the properties of basic of tin monoxide. So when basic react with acid, so you will get, okay, water molecule. Okay, and then what is the remaining here? Tin and Cl. So tin dichloride. Okay, and then balance the equation. Right, and then last one is, okay, we write the lead monoxide here. Okay, and then react with hydrochloric acid here. Okay, and then basically this is the neutralization process, so it will form water molecule. Okay, and then the remaining is lead and Cl, so it will form lead dichloride. Okay, so and then balance the equation. Okay, so now we continue with reaction of amphoteric for germanium dioxide. Okay, tin dioxide and lead dioxide actually is same. Okay, so now, okay, let's write the reaction of germanium dioxide, okay, with HCl. Okay, HCl, okay, is also germanium dioxide act as a basic which react with acid, so it will form water. Okay, and then plus the remaining germanium and Cl, so we get germanium tetrachloride. Okay, and then balance the equation, so it have 4 chlorine here, so 4 hydrochloric acid. So why for germanium dioxide we get germanium tetrachloride? Okay, because germanium dioxide is, we use the germanium of positive for oxidation state, so we will get the germanium tetrachloride. Okay, why for germanium monoxide? Okay, why we get germanium dichloride? Because we use germanium monoxide is the positive to oxidation state, so we will get germanium dichloride as a product. Okay, now, okay, back to tin, tin dioxide. So tin dioxide, okay, when we react with acid, okay, so, okay, first we will get water here. Okay, and then, so the main product, we will get tin tetrachloride. So 4 chlorine here, so we balance the equation. Okay, and finally, okay, write down for lead dioxide reaction, okay, which acid, so we will get water here. Okay, and then, so the main product is lead tetrachloride. Okay, and then balance. So this is the reaction. Okay, back to chemical equation of amphoteric of dioxides of group 14. Okay, make sure that you write the correct chemical equation and balance the chemical equation correctly. So here for the chemical equation, so I have seen that they have unbalanced yet. Okay, which is we must balance it with 2 water here. Alright, so okay, already balanced. So same goes to tin dioxide, balance it here and here. Alright, then we get the balance equation of amphoteric of dioxide with acid. Okay, so this part, which is this amphoteric of group 14 compound, okay, are acting as basic lah. Alright. Okay, I want you to take note for the reaction of lead dioxide reaction with hydrochloric acid. Because if you can see here that this lead tetrachloride is unstable. Alright, so okay, actually for lead dioxide, when it react with hydrochloric acid, okay, and then it will form okay, water first, okay, and then lead tetrachloride here, okay, 4 and 2 here, 2 more. Alright, so actually this reaction is only occur in a cold condition, which is the temperature is less than 5 degree Celsius. So this is positive for oxidation state of lead, so which is unstable. Okay, when it reach more than 5 degrees Celsius, actually this lead tetrachloride will decompose into lead dichloride, okay, and chlorine gas. Okay, when the temperature reach more than 5 degrees Celsius, it will decompose easily into lead dichloride and chlorine gas. So hence, so the reaction of lead dioxide, okay, when it reach room temperature, actually it will form, okay, HCl. Okay, actually the product form in room temperature is lead dichloride plus chlorine gas and followed by water. Alright, so it balance it, okay, for HCl here and 2 here. So this is the reaction occur when the temperature reach more than 5 degree Celsius. Alright, so you must take note this part. Now we continue with effluentaric of monoxide, okay, with base. So now germanium monoxide, okay, we react with sodium hydroxide, NaO, okay, as we do for aluminium before. So we must plus with water molecule. Okay, so this reaction that shows that germanium monoxide is act as a acidic because it react with sodium hydroxide. Okay, so what we get is, so germanium and water, okay, we get the germanate, okay, which is H4. So sodium and then sodium 2. Okay, so the reaction, okay, and then balance the equation, we get 2 mole of NaO. So we will get sodium germanate 2. Okay, sodium germanate 2. Okay, second one is tin. Okay, we have seen tin O, okay, react with sodium hydroxide. Okay, don't forget to plus water molecule. Okay, and then we will get stannate. Okay, tin, okay, OH in bracket 4. So this one is stannate. Okay, and then we have sodium here, so sodium 2. Okay, and then balance the equation. So this is we call sodium stannate 2. Okay, and then final for monoxide, we have lead monoxide. We react it with NaO, okay, followed by water molecule. Okay, and then it will get, okay, lead with water, we get hydroxide 4 here. Okay, this is we call plumbate 2. Okay, so we have sodium metal, okay, so sodium 2. So balance the equation. So this is we call sodium plumbate 2. Now let's write the chemical equation of germanium dioxide, okay, to sodium hydroxide, which is this germanium dioxide, tin dioxide and lead dioxide, okay, are add as a acidic. Okay, so now germanium dioxide. Okay, we react with sodium hydroxide, and don't forget to follow by added water. Okay, and then it will form the complex compound. Okay, which is, okay, we have germanium and water here, so GeKOH and 6. Okay, because we use positive for oxidation state of germanium. Okay, and then we use sodium metal. Okay, and then sodium. So this kind of complex we call it as sodium germanate 4. Okay, sodium germanate 4. Okay, while for germanium oxide, it will form complex of sodium germanate 2 because we use the positive 2 oxidation state of germanium. Okay, then we continue with tin dioxide. So we have tin dioxide. Okay, we plus 2 sodium hydroxide. Okay, followed by water. Okay, and then it will form sodium standard 4. Okay, so we have tin hydroxide 6 here. Okay, and then sodium 2. Okay, so this is we call as a sodium standard 4. Alright. Okay, then don't forget to balance the equation. Okay, so start from germanium dioxide. Okay, we forgot to balance. Okay, so now 2 mole of NaOH and 2 mole of water molecule, and then okay, it's already balanced. Okay, sufficient each. Okay, then for tin dioxide also we have 2 mole of NaOH and 2 mole of water molecule. Alright. Okay, lastly for amphoteric of dioxide, okay, we have lead dioxide. Okay, we have lead dioxide here. Okay, so now we react it with NaOH. Okay, and also water molecule. Okay, then it will form, okay, lead and water. Okay, so we have lead. Okay, and then hydroxide there. Okay, 6. Okay, and then we have sodium here, so sodium 2. So this complex compound we call as a sodium plumbate 4. Okay, sodium plumbate 4. Okay, and then don't forget to balance the equation. Okay, now I want to explain why group 14 element can form complex compound. So this is we call a complex compound, which we will learn about this in detail in a transition element chapter. Okay, now I want to explain a little bit lah. Okay, so now if you can see here, this is the example. Okay, I take from the reaction of germanium oxide with sodium hydroxide and water, which is it will form a complex compound. Okay, now okay, when we take a look, okay, one by one, so this is sodium ion, and this is the, okay, so 2 meaning to charge 2 minus. So this is the anion complex. Alright, so first how to know the oxidation state of germanium here. So we can calculate as usual. So germanium, okay, we plus 4. Okay, and hydroxide ion have a negative 1 oxidation state. Okay, equal to negative 2. Okay, then we will get that germanium is a positive 2. So that's why germanium can form anion complex, can form complex compound. Alright, the first thing is because germanium and tin and lead in a group 14 element have a empty 3D orbital. So that's why it can form complex compound. So in order to form the complex compound, okay, Okay, the first one, we must have central metal. Central metal. So this central metal must have empty d orbital. Okay, so like germanium atom. So germanium atom can act as a central metal in complex compound because it have empty d orbital. Okay, second condition, to form complex compound, it must have ligand. Ligand. Because this ligand must have the lone pair, which is this lone pair will donate to the empty d orbital to form. And third condition, it must form dative bond. So this is the three condition in order to form the complex compound. Alright. Okay. So now, same goes to germanium dioxide. Okay. So I want to show how to calculate the oxidation state of germanium in this compound. So we just separate first, ionize first. So we have sodium ion here and then complex ion, which is 2 minus. Alright, and then so germanium plus negative 1. Alright, and then 6. You have 6 here equal to negative 2. So this germanium have positive for oxidation state. So because we use the germanium dioxide. Okay, now how to show why germanium can form complex compound. Alright, so first germanium, let's rewrite the electronic configuration of germanium atom. I use the shorten electronic configuration. So we have 3d10, we have 4s2, we have 4p2. Alright, and then valence equation here. Germanium atom, so we have 4s and 4p. 4p. So now is our anion complex involved. Is here, which is we use germanium 4 plus. Alright, so now we want to form germanium 4 plus. So in order to form germanium 4 plus, we must excite first the electron to the higher energy level. So we get 4p 111. Alright, so now we want to remove 4 electron. We want to remove 4 electron. So we remove all the 4 electron. So now we have so we have 4s, 4p, and don't forget that germanium also have 4d. 4d orbital. Alright, refer to the ligand. Ligand involved here is hydroxide ion. So we need 6 hydroxide ion. And for hydroxide, you know that for hydroxide ligand, it consists of 3 lone pair, but we only want to use 1 lone pair. So we want to use 6 ligands, so we need 6 empty orbital. 1, 2, 3, 4, 5, and 6. So we will use the 6 orbital to accommodate the 6 hydroxide ion. So each hydroxide ligand will donate its lone pair to the empty orbital in germanium 4 plus. Alright, then we can draw the structure. Alright, so now because of this is 6 ligand, coordinate 6, so it will form octahedral shape. Okay. Okay, we form octahedral complex. Okay, so now this is the complex form. Okay, and then 2 minus. Okay, so this will form complex anion complex. Okay, which is H C2 minus. Okay, then we bonded with an A plus. So we will form the compound Na2. Okay, and then germanium. Okay, alright. So we will form sodium germanate 4. For acid base property of group 14, okay, we already covered about, which is carbon monoxide and silicon monoxide. Okay, both are neutral. Okay, neutral. Okay, and then we have germanium oxide. Okay, we have tin oxide and lead oxide. Alright. Okay, also for monoxide, we have germanium dioxide for dioxide and class. Okay, for germanium dioxide, for tin dioxide, and for lead dioxide. Okay, all of these 6 compounds are amphoteric. Okay, now left another 2 compound, okay, which are carbon dioxide and silicon dioxide. For these 2 of dioxide compound, okay, these both, okay, are acidic. Okay, so this acidic compound, okay, of carbon dioxide and silicon dioxide, if we react with base, which is example sodium hydroxide, to form water. Okay, for water and any compound lah. Okay, so now let we write the chemical equation. Alright, so first carbon dioxide. Okay, when we react with sodium hydroxide, okay, we will get, okay, first is water molecule and we get sodium carbonate. Okay, sodium carbonate compound. Okay, then we balance the equation. So this is the reaction of carbon dioxide with base. So it will get salt and water. Okay, number 2 is silicon, okay, dioxide. When we react with sodium hydroxide, okay, we will get first is water molecule and the salt form is, okay, sodium silicate. So this is sodium silicate. Okay, sodium silicates. Okay, and then balance the equation. So we already covered about acid base property of group 14 compound. So you must memorize the acid base property of this compound.